Hello, John Cheek here from UniTasterDays, and today we're going to be looking at university courses in astronomy. You can see on the screen here that we've got our content checklist in terms of what you can expect on this astronomy introduction. But ultimately, it's going to be looking at why you might want to consider astronomy, what to expect on it if you do study it, application tips and careers. And I'm joined by an award-winning astronomer and also a professor at the University of Birmingham, and that is Professor Amaury Triaud. Amaury, over to you.
Hi, my name is Amaury Triaud. I'm a professor of Exoplanetology at the School of Physics and Astronomy at the University of Birmingham. In this video, I will show you what it is like to study astronomy and astrophysics at university level, including some tips about applying for these programs. But first, let's see, why would you choose astronomy? Well, astronomy is a science of the universe, and some of the questions we tackle scientifically have been philosophical questions for centuries, sometimes millennia. So if this is the sort of thing that you are interested in, then astronomy is likely for you. Astronomy is also a strange science compared to physics, for instance. In astronomy, we are about inferring the laws of the universe without being able to control them. Contrary to physics experiment, for instance, where you can control a variable and you turn a couple of knobs, in astronomy, we are the experiment, and we can only make sense of the universe via careful observation of the night sky. This means that astronomy teaches many skills that are highly valued later in life. Before going into the content of your degree, let me first describe a bit the type of degrees that exist out there. Programs of study of astronomy have different names in different universities in the UK. For instance, ours at Birmingham is called Physics and Astrophysics, but many of these programs have very similar contents. If you want to find out a little more about those, I invite you to go to http://myphysicscourse.iop.org at the bottom of your screen. Now, what will you be studying? Well, all sorts of things. As a student, you might learn to analyze data from gravitational wave detectors and witness black holes as they merge far into the universe. You might model the interior structures of stars by measuring seismic activity on the surface of the sun and other stars. You might learn how stars are born, evolve, and die, creating and liberating the atomic elements that make us and everything you see around you on Earth. You might also learn about the assembly of our own galaxy, the Milky Way, with its 300 billion stars, a topic called galactic archaeology. You might want to understand cosmology, the study and the story of our own universe, dark matter, how galaxies form, merge, and evolve, in order to understand our current observation of this universe and using state-of-the-art telescope as they're coming online. And finally, there is my own topic of research, the discovery of exoplanets, such as the TRAPPIST-1 system with its 7 rocky Earth-like planets orbiting an ultra-cool dwarf. These new worlds are putting us on a path to search for life elsewhere in the universe. Now, all of those topics will be taught to you usually in formal lectures, typically in year 3 and year 4. During year 1 and year 2 in most programs, you will spend your time learning physics in order to construct a strong foundation in physics. Depending on the university, this means classes sometimes with several hundreds of students, which is very different from school. During year 1 and year 2, you will also be introduced to astronomy and start doing some labs specific to astronomy, typically data analysis, observations with a telescope, etc. The reason these programs start with physics is because in astronomy, we have to contend with many physical laws all at once. And that's actually what makes it fascinating, what I like, instead of isolating effects that can happen in a physical experiment. Some of the classes that you will do will also cover model comparison and statistical inference, which teach you how to make sense of the world around you simply from observation, from data. And those are actually probably the most interesting skill you will develop during the program for future use in a career. In addition, what you should expect is to take part in small group tutorials. Being integrated in a physics program, this is rather usual. These groups typically have 4 to 5 students, and during these first 2 years, during the small group tutorials, you work on exercises and you learn other skills necessary to become an accomplished individual. For instance, you will learn the ability to report your result, write a paper, present slide, creating meaningful graphs, etc. And sometimes we use, and I use those tutorials in order to talk about future careers, find internships, write CVs, etc. Those tutorial sessions, you also have the time to ask more profound questions and revisit the concepts that you have seen during your lectures. Another aspect of a typical astronomical program is lab work using telescopes. And most universities have access to their own telescope. For instance, the building that you see right now is a small building in the south part of Birmingham. Using these telescopes, you will learn to operate and analyze the data, everything that a professional astronomer is expected to do. In addition, many leading observatories, whether they are on Earth or in space, make the data public. So you can also use those data during labs in order to hone in your skill at analyzing data. These astrolabs will teach you data analysis, how to think like an astronomer, to tease out meaning from data. And all of this is done such that by year 3 or year 4, as an undergrad, you can engage with researchers and make your own discoveries. For instance, the year 3 students that we have in Birmingham engage in group studies. They solve a big problem. And to do that, they will create a team very much like you would do in a company or in a research team. They decide the hierarchy of the team. They decide the tasks that are needed in order to solve that problem. And then they work together and produce one report. Regularly, this kind of work also means working with data from satellites and top work facilities. In year 4, things are a bit different there. Students are expected to show their ability to research on their own. And you will spend about 50% of your time working with lecturers in order to produce an original piece of research. The type of project you would end up doing depends very much on the research and the facilities accessible to that particular university. For instance, what you see here on the screen are some of the telescopes we have access to in Chile. It will also depend on your own choices and the availability of projects within that university. And students of mine have in the past worked on, for instance, finding out whether volcanoes could be detected on exoplanets. We've looked at calculating new detection limits to assess our ability to detect exoplanets using the radial velocity method, and applying machine learning methods in order to detect clouds in all sky cameras in order to trigger the closure of the domes of the telescope that you see in to avoid rain falling into them. Regularly, final year students participate in making new discoveries during the degrees, and those that do will co-author scientific papers. And I have co-authored several refereed scientific papers with past students. Now let's move on to tips about your application. I think the most important for me is that you should visit the campus, talk to the staff, and see if you feel at home there. You should check the entry requirements so you don't apply to a university that doesn't quite fit what you want. And you should look at how flexible the degree program is. For instance, how likely or how easy it is to move from, say, a physics program to an astrophysics program, or vice versa, depending, if you want to change your mind, for instance. And most of the time it is easy, but worth asking for it. Then my next step would be to find a list of the classes in order to see if there is what you are interested in. If you like black holes and the university doesn't teach anything about black holes, then maybe that will tell you where not to apply and narrow down your choice. Ask also about support to find your future career and how integrated it is within the degree. And finally, and importantly, some universities offer partial scholarships and financial help, which should guide your access and your choice. Now let's move on to the kind of career astronomers can do. There is that idea that astronomers will do astronomy later, but in fact, most of our skills are eminently portable to other fields of research or even to the wider society. And typically, data science, industry, and finance are where you will find the most former astronomers. The reason is because dealing with astronomical data is similar to any work related with data, which is these 3 areas in particular. And our skills in mathematics, data analysis, and the inference of pattern from data alone are very helpful. Data alone without experimentation. Taking an example, Google or Netflix have never asked you what you wanted to watch tonight. They infer it very much in a way that we infer the laws of nature from the observations of galaxies, for instance. Hence, skills learned during an astrophysics degree can be immediately put to use in the real world. Other careers include teachers, patent lawyers, journalists, code developers, university researchers such as myself, policy advisors, or project managers. Several of my former students now work in the space industry, one of them working in a lab, creating an instrument that will be landed on Mars eventually, and one has even founded his own startup company using machine learning skills that he has learned during his degree. So that's it for me. And if you have any question, you can contact any university admission service Thanks for your attention.